Hello, Colonet Africa Online School. Welcome to our lesson on this topic of hydrogen and its compound. And today we are going to look at the reaction of metals with steam. And we're going to first of all to start by describing an experiment that is normally used in most of the metals that are reacted with steam. And mind you, in this case, you cannot react very reactive metals such as calcium, potassium, and sodium with steam, because that reaction may be very dangerous, because those metals are very reactive and can react dangerously with steam. So please piece a clean wet sand in a boiling tube. Clean a piece of magnesium ribbon about 6 centimeters long and make it into a spiral coil. The magnesium ribbon is coiled in order to increase the surface area in contact with the boiling tube. Place it in the middle of the boiling tube and arrange the apparatus as shown in the figure alongside. This is the figure that is normally used in the reaction of metals with steam. So the experiment is set up in this manner. So we have the wet sand, and this wet sand has some water. So if you heat, you're going to get or to transform the water into steam. Steam is water in gaseous form. Then we have the magnesium ribbon. Remember, we said that it has to be spiral, and you're making it spiral so that you can increase the surface area for the reaction. Remember, once you increase the surface area, you increase the rate of reaction. Then you have to heat the magnesium ribbon. Then this is our hydrogen gas that is being obtained, and you can see these bubbles indicate that there is that production of the hydrogen gas. So that's the setup that is normally used when you are reacting metals with steam. And heat the magnesium strongly and warm the wet sand gently as you continue heating the magnesium. Observe what happens. Remove the delivery tube before you stop heating. The delivery tube is removed before heating in order to stop or to prevent the water from being sucked into the boiling tube as it cools. Test the gas produced using a burning splint. Record your observation. Repeat the experiment using zinc powder and iron fillings. The iron fillings must be fresh. Alternatively, use steel oil. The reaction with magnesium metal. So the wet sand is warmed to generate steam, which reacts with metals. Some metals such as magnesium do not react with cold water. Remember, we found that magnesium has a coating on the surface of the metal, which is magnesium oxide. When magnesium is exposed to atmospheric air, it combines with atmospheric oxygen to form magnesium oxide, which prevents it from reacting with cold water. But it can react with steam. If you increase the temperature, it increases the rate of reaction. Magnesium burns brightly in steam to form white magnesium oxide powder and hydrogen gas. Magnesium plus steam gives us magnesium oxide plus hydrogen gas, and that is the word equation. Then this is the chemical equation. As I said earlier on, magnesium is solid at room temperature because it's a metal. Then in this case, you can know the difference. When you come to this reaction, we are using the steam, and I say that steam is water in gaseous form, and that's why you have a G for the state symbol. Then we have magnesium oxide, it's solid at room temperature. Then we have hydrogen gas, is normally a gas at room temperature, so you use a state symbol of G. Then reaction with zinc, you're going to find that zinc and iron do not burn in steam, they just glow. Zinc reacts with steam to form a yellow powder, which is zinc oxide. So zinc oxide when hot is yellow, which turns white upon cooling, which is a physical process. So you're going to find that if you have zinc oxide, if you heat zinc oxide, you get a yellow solid. Then that yellow hot solid, which is zinc oxide, if you cool it, it turns white. Remember, it's still zinc oxide, and that's why you're calling it a physical process. You're just changing the states. But when you heat zinc with steam, there's a chemical reaction that takes place. You get a zinc oxide and hydrogen gas. So that's a chemical reaction. So the formation of yellow powder from zinc metal is a chemical reaction. The formation of a white solid from the yellow solid upon cooling is a physical process. So this is the equation, zinc plus steam. So it's a word equation to give us zinc oxide plus hydrogen gas. Mind you, in this case, when you're reacting with steam, you don't get a hydroxide. Rather, you get an oxide. You have to know that very carefully. In the previous reaction between metal and the liquid water, we were obtaining a hydroxide. But in this case, with steam, you get an oxide. And this is the chemical equation. Then iron forms a black residue of an oxide called triiron tetraoxide and hydrogen gas. And this is the word equation, iron plus steam, triiron tetraoxide plus hydrogen gas. That is the chemical equation. Then reaction of steam with aluminium. So aluminium reacts with steam but quickly forms a layer of aluminium oxide which prevents further reaction. This is why most of cooking utensils are made up of aluminium. Lead and copper do not react with either cold water or steam. Lead has a thin layer of lead 2 oxide which prevents it from reacting with water. In summary, this table gives a summary of the reaction of metal with cold water and steam. We have the metal, the action of water on metal, and the action of water on steam. Potassium reacts violently with water in liquid form, but with steam it reacts explosively, so it's very reactive. Sodium, the same case, it's violent with water and explosive with steam. Calcium reacts moderately with water and violently with steam, and that's why these three metals are not advisable to experiment them with steam. So you cannot just take potassium then you react with steam. That reaction may be very dangerous in the lab. Magnesium reacts very slowly and with cold water and rapidly with steam. Aluminium, zinc, and iron, they don't react with cold water, but they react slowly with steam. Lead, we don't have any reaction, no reaction with steam. Copper, there's no reaction with cold water, no reaction with steam. And this table summarizes the reaction of metal with cold water and steam. Then let's look at the reactivity series of metals based on hydrogen or on their reactivity with water. Metals can be arranged in the order of their reactivity with water, and the arrangement gives the reactivity series of metals based on how they react with water. The most reactive metal is potassium. The least reactive metal is platinum. Carbon and hydrogen highlighted with red are non-metals. So carbon and hydrogen are not metals. They are non-metals. And this is the reactivity series based on how these metals react with water. And this is potassium. It's the most reactive. And this is the word, and this is the symbol. So this represents the symbol, this represents the word of those elements. So carbon is a non-metal, hydrogen is a non-metal, then all the others are metals. So all the others are metals. So the most reactive is potassium, followed by sodium, calcium, magnesium, aluminium. Then we have the non-metal carbon. Then we have zinc, iron, tin, lead. Then we have the non-metal hydrogen. Then we have copper, silver, gold, and platinum. And that's why you can see if you look at copper and also the lead, they are very close to hydrogen, so it is very difficult for them to displace hydrogen from its compound, and that's why he found that lead and copper do not react with cold water, and also they do not react with steam. Then that brings us to the end of our third lesson in this topic of hydrogen and its compound. You have the assignment. This assignment entails 6 questions, so make sure that you answer all the 6 questions. And once you answer all the 6 questions, then you can test how you have assimilated and acquired the knowledge in this topic. So we meet next time to discuss the fourth lesson in this topic of hydrogen and its compound. Thank you. Goodbye.